is all about quadratics, which means, some of you guys have already looked at the page and figured out, parabolas. Okay, so yes, we're going to do some graphing. Now, you have the whole packet of notes in front of you. If you flip through all of it, are we graphing every single lesson? No. There are several lessons that involve graphing, but it's not all graphing. Okay, however, to work with parabolas, we do need to be able to graph them. So today we are specifically talking about vertex form of a quadratic function. And so a couple of forms to get out of the way here. So a quadratic function is of the form f of x equals ax squared plus bx plus c. So you're familiar with that form, ax squared plus bx plus c. You see that x squared, we know it's a quadratic. Quadratic meaning it has a high power of x to the second. Okay. Now, all quadratic functions are transformations of the parent function f of x equals x squared. Early on in topic 1, we did a little bit with f of x equals x squared, didn't we? We had that basic parabola we did a little bit of moving with. We're just going to do a lot more with it now, okay? Graph of a quadratic function is a parabola. We already mentioned that. Today, our big focus is the vertex form. So, vertex form of a quadratic function is f of x equals a times x minus h, quantity squared, plus k. And what's helpful about this form is h and k is the vertex. Okay? You see this nice little box chart. Does it look familiar?
Mm-hmm.
Yes.
It comes back every unit for the first several units. So this chart is literally copied and pasted from the previous chart. Okay, so it's exactly what you saw in Chapter 1 notes. So that green paper still applies that had all of these transformations on it. I'm not going to go through it. You're familiar with it. We'll talk about it as we use it. Now, basic parabola. What chart did I have you use in first unit? If we had to graph the basic parabola, what did I have you guys remember? It's that U that has the vertex at, okay, yeah. Vertex being at 0, 0, and then we had points at 1, 1, 2, 4, and that would make up the right side of the parabola, and then we could reflect it to get the left side of the parabola, right? Okay. What's the vertex of this? Vertex of this is 0, 0. And what's the axis of symmetry? X equals 0. Okay. We had some of that same type of questions, except more detailed, on our last test. A little bit more information, and this is just specific to a parabola. We have the A value, which we have the A value up here in our chart. When we talk about the A value, we think of it as a vertical stretch or compression, right? Obviously, still true on a parabola. It's going to be your stretch or compress. Important, though. If A is positive, your go-to needs to be, okay, it's a positive A value. I know my parabola is going to open upwards. What happens when my A is negative then? It's going to flip upside down, right? And that negative is the reflection there is what it is. But we don't necessarily think that with parabolas. We just know positive up, negative down. If A is a fraction between 0 and 1, then it's compressed, vertically compressed. If A is a number greater than 1, the graph is stretched. So important information to know as we talk about parabolas. Now, I really don't think you'll mind the graphing that we start with today. In that, this is very much like graphing that we did first unit. Okay? This is just, we used a little bit of Desmos to get us started this year, but now it's all about graphing it by hand. So, describe the transformations of the parent function f of x equals x squared, and then graph it. So, thoughts on what you see happening here? You have your chart at the top of the page. Okay. A -1 inside the parentheses is going to be left or right, opposite the sign of the direction, correct? Opposite the direction of the sign, correct? Okay, so that is going to be a right 1. And then the +2 is up or down the direction of the sign. So since it's a +2, We're going to go up to, aren't we? Now, if we describe those in official words and sentences, which you guys did a pretty good job on the test about this, what's the best vocabulary word we're going to use? Translated. So I'm going to write that we translated, or we're going to translate, I guess, right one and up to units. Okay. Yes, I saw words like moved, shifted, things like that. That's fine too. So, can we graph this parabola? This part's kind of review, isn't it? Normally my parabola starts at 0, 0. Where's it going to start at now instead?
1, 2.
Okay, we're going to go right 1, up 2. There's my new starting point, or in other words, my new vertex. What about from that point? Where am I going from that point? Paul?
Don't you go up 1, over 1, and then up 2? What? Up 2. Right 4. No, over 2. Up 4.
Okay. Get them in the right spot order, and I think you would graph them right. But yeah, so we have the first set of points that goes over 1, up 1. The second set of points from the vertex goes over 2, up 4. The left side is going to be symmetric. So left 1, up 1, left 2, up 4. Please remember, when you connect your parabola, try, and make it look more U-like than V-like. It's so easy to make it look like a V. And then, let's see. On this one, I did not ask for vertex and axis of symmetry, but I know we could do that as well. Okay. Old news? Not horrible, is it?
No.
Okay. Let's do this one real quick. B, f of x equals the negative of x plus 2 quantity squared. What's that negative going to do? That is going to be a reflect, isn't it? And specifically, I'll write it down here, it's going to be a reflection across the x-axis. What other pieces do we have here? Okay. There's a plus 2 inside the parentheses, so left or right, opposite the sign. So plus 2 is going to tell me to go left 2. And that means we are going to... There we go. Thank you. Translate. Left 2 units. Anything else?
We got to do something with that exponent.
What's the exponent indicate?
I don't know.
The exponent just says, oh, this is x squared, which means my basic shape is a parabola.
Oh.
Okay? So that squared, don't think, and I know I've seen sometimes people say, oh, 2 squared is 4, I'm actually moving 4. No. That squared is just part of x, and so when I see x squared, that's what tells me, okay, I'm graphing a parabola. Not a V, not anything else, the parabola. Okay? So... translate left 2 says I'm going to take my vertex and go left 2. What's this reflection mean?
Down.
Yeah, instead of counting up, I'm going to count down. So technically, we're doing our reflection first, really. Okay, so technically in our brains, we need to be flipping it upside down first and then moving it. But the way we draw this, I have us move the vertex and then draw the new graph, which... to me, that's what's logical. So from here, I'm going to count over 1 and down 1, over 2 and down 4. Over 1, down 1 on the other side, over 2, down 4. Okay, we got a little bit of the basics out of the way. Let's go. Keep going. C and D are on the back side. C and D, we're technically doing the same thing. Describing the transformations and graphing. There'll be an extra little step here. But overall, same deal. So what do you notice about C? F of x equals 2 times x minus 1 squared minus 3. What are the pieces you can identify?
Vertical.
Go ahead. Ah. And that's the piece we'll have to figure out how to graph, right? So there's going to be a vertical stretch by a factor of 2. I'll go ahead and write it down here. Vertical stretch by a factor of 2. What else you got, Ruby? Okay. Plus or minus a number at the end is up or down, direction of the sign. So that is going to translate down 3. And minus 1 in those parentheses goes opposite the direction of the sign. So that's going to be right 1. So I'm going to translate right 1 and down 3 units. Okay. So the easy part. Where's my parabola going to start?
-1. No. 1, -3.
Right 1, down 3, so 1, -3. Yes?
Yes.
The trickier part. The stretch. Have we talked about how to do these stretches? A little bit, but I don't know how much we've truly talked about it. Okay. And there's a couple different ways I can teach this, okay? When it is a V, we can just use that as a slope, yes? This isn't a V, folks. We can't just use it as a slope, okay? It doesn't work quite like that. So my recommendation, okay, let's start with the basic graph. Y equals x squared. What do you know about y equals x squared? Our basic XY chart is what? 0, 0. 1, 1, 2, 4, yes? Because if you put 0, 1, and 2 into there, you get 0, 1, and 4 back out, right? Okay, now, what I want us to think about is what does y equals 2x squared look like? Using the same basic 0, 1, 2.
2, 3, 6.
Not exactly. When you put 0 in here, what's 0 squared times 2 is still going to be 0, yes? What happens when we put 1 in? Now keep in mind, this is 2 times 1 squared, right? So 1 squared is 1 times 2 is 2. What about this other one? 2 squared is 4 times 2 is 8. Now, here's my shortcut. Rather than thinking about plugging these in, what's the relationship between this y column and this y column? 0, 1, 4 became 0, 2, 8, which means what did we do? You multiplied each of those numbers by 2. Okay, that's what I generally try and teach when I'm trying to teach a stretch or a compression, is take these basic y values of 0, 1, 4. In this case, since it's a stretch by a factor of 2, multiply them by 2. Okay? Now, I know some of you will catch on, and this is helpful in Savas where you only have to graph 1 point. You kind of can just think about that first point as kind of a slope in a way, but it doesn't work past that first point. So that's why you can't rely on it as a slope. So, my suggestion here, we have our new vertex, yes? From our new vertex, instead of going over 1, up 1, over 2, up 4, we're going to go over 1, up 2, and over 2, up 8. We are going up, yes? Yes. We don't have any reason. I can't remember if there's a reflect on this. So that's my recommendation. So right here, where we went, right 1, down 3, that's my vertex. From this point, normally it'd be over 1, up 1. I'm going to go over 1, up 2. I'll go ahead and do that both ways, over 1, up 2. Instead of going over 2, up 4, I'm now going to go over 2, up 8. Same thing on the left. Instead of over 1, up 2, or over 2, up 4, over 2, up 8. Or just reflect it. We stretch this graph. What does it look like it?
Yeah.
It's skinnier, right?
Yeah.
Taller, skinnier. That's what a stretch graph should look like. Okay. My recommendation of how to do the stretch. Not the only way, though. So far, so good?
Yeah.
Okay. Shall we try D then?
Yes.
G of x equals -1/2 times x plus 2 quantity squared.
Vertical.
Why are we saying compression?
Because that's less than.
Okay. So here we're looking at 1/2. 1/2 is less than 1. So that makes it a vertical compression, yes? Mm-hmm. So instead of my parabola getting taller and skinnier, it's going to get shorter and wider. Yeah. Trying to use appropriate wording there. Okay. What else do we see happening here?
Across the x-axis.
Okay, we have a negative, don't we? That negative says this is going to reflect across the x-axis, which means we're going to be, instead of right side up,
Upside down.
Upside down. And plus 2. Inside the parentheses is going to be left 2. So write it all out. I should have been writing as I went here.
Would be a factor of 1/2 or just -1/2?
So it's going to be a vertical compression by a factor of 1/2. The negative is the reflection.
Okay.
So vertical compression by a factor of 1/2. Then for the negative, I'm going to mention that it is a reflection across the x-axis. And what else did I have? Translate left 2 units. Okay. Where's my vertex going to be?
Negative.
Yeah. Left 2? No up or down. Okay. Now, we know the reflection is going to make it go upside down. Okay. We've got that in our brains, I think. The compression by a factor of 1/2. Are you seeing where I'm going to go with this? Oops. We know y equals x squared has the basic 0, 0, 1, 1, 2, 4. Okay. Now, while I'm here, and this is because I know what's coming, if you were to continue this chart past 0, 0, 1, 1, 2, 4, what are other values we could continue with?
36.
Check yourself. Wait, back up to the 3 for a moment.
39.
Because it's x squared.
4, 6.
So 3 squared is 9, 4 squared is 16. Okay, that makes me happy.
5.
Stop there for a moment. Yeah, exactly. We could keep going on and on and on, but there's a reason I'm doing this. Because which values are we going to be needing? we have to do values that we can do a half of. Okay, so 0, 0 is good. What's going to happen with 1? You're going to have to take this 1 here and multiply it by 1/2. What's half of 1?
0.5.
0.5, 1/2. Do you want to graph that?
No.
I mean, you can, but it's not the easiest or most fun thing to graph. Okay, so 2, 4. 2 stays 2. What's the 4 become?
2.
2, because half of 4 is 2. Okay, 3, 9, it was just the next in the rundown. That's why I put it in there. 3, what's half of 9? 4.5. Is that really what we want to graph? Not necessarily, which is why I did go 1 more. 4, 16. The 4 stays 4. What's half of 16? 8. So, I mean, basically in all of these, what did we do? We took the y values and multiplied by 1/2. Now, what I want from you is obviously that represents our basic. I want 2 other good pairs. If you really want to graph 1 over and a half up, go for it. But I'd rather use the ones that give me nice, neat whole numbers. Does that make sense?
Yeah.
Okay, so those are kind of what I'm going to use to represent it. Okay, you got your brain together? We already took the vertex and moved it. Left 2. From this new vertex, where are we going to go?
Right 2, up 2.
Okay, right 2, up 2.
And left 2, up 2.
And that means I'm going to go ahead and go left 2, up 2 on there.
Going upside down.
Undo. Undo. Thank you. Okay. Hopefully you weren't doing that in ink pen. Sorry. Nope, thank you guys. Okay. I should have probably asked before we started graphing those points, are we right side up or upside down?
Upside down.
We were supposed to be reflecting. So, right 2, down 2. That means left 2, down 2. And right 4, down 8. And left 4, down 8. Okay. And that's something you could have done. Another option, and maybe I should have because I made the mistake. Another option is, could we have just left the negative with the 1/2 here and put these as negative values as a reminder to us? We could have. And maybe I should have because, I messed it up. But, yeah, pretty much. Okay. If you compare this graph to the graphs on the front page, it should look a little bit wider. Okay. You guys want a funny here?
No.
My notes are wrong. My notes have this graph going right side up.
Oh.
Hopefully I taught it correctly last year. I'm assuming I did. I just didn't even notice it was wrong in my notes. I don't always watch my notes very closely, so. Yes.
So I might mess this up. Whenever you do the 4 and the 8, you go off the base one, right?
You're going back to the original vertex, yes. Yeah, and just think about like the 2, 4. I always go back, that's 2 over from the original vertex and 4 up or down. Okay. Whew.
That's it for today?
No, we can do a little bit more. We don't want to save the rest of all of this for tomorrow. Now, I will say, am I getting through all my notes today? No,
So no.
I already knew that.
So no homework.
So you can start the homework,
No.
but you're not going to necessarily be ready to finish it all, and it's not due tomorrow.
Nice.
Okay, now, the more I get done today, though, the more chance you have of having some work time tomorrow. That's the benefit.
But if you don't get much done tomorrow, then the homework's not due until Thursday.
Homework is due Wednesday, period, end of statement.
Well, what if we don't get done with the notes?
We're getting done with the notes. If that means me having to kick you out of class, we're getting done with the notes.
Why would you do that?
Okay, key features of a quadratic function. Okay. I mentioned on the front page, vertex form of a parabola. You're going to start seeing this more. The a times x minus h squared plus k. Key pieces of information there. Your vertex is hk. We've already talked about that some. That h and k are how far you move left or right and how far you move up or down. That means your axis of symmetry is x equals h. Well, that's just, it's always the x value from the vertex, right? That's old news. New news. The vertex of the parabola is either the maximum or the minimum of the graph. Okay? It's either a maximum or a minimum of the graph, meaning if I have a normal everyday right side up parabola, where's the vertex at? It's at the bottom, yes? If a vertex is at the bottom, is it going to be a maximum or a minimum?
Depending on if it reflects it.
No, just if I have a right side up parabola, is that point a maximum on the graph or a minimum?
Maximum.
A minimum?
Minimum.
Okay. That is a minimum because it is the lowest the graph will ever go. Okay. That parabola will never go below that vertex. As opposed to, what about this? Where's my vertex at here?
Maximum.
It's a maximum because that is the highest. It doesn't matter how far I extend that parabola. That vertex is the maximum there. So that's a little bit, we're going to use those words maximum and minimum. But if it's a right side up parabola, your vertex is a minimum. It's at the bottom. If it's an upside down parabola, your vertex is at the top and it's a maximum. Okay. Domain and range, they haven't gone away yet. Okay, those are big things in Algebra 2. Domain, how far left and right does a parabola go?
Infinite.
It's going, as it's moving either up or down, it's going infinitely, yes? So, easiest question you'll have in homework. Domain, anytime they ask you for domains of these parabolas, it's always going to be negative infinity to positive infinity. Or, in other words, all real numbers. All numbers are included. Okay. And then we'll talk about range, and I'll go through an example with that. Range is going to be based on that y value. Okay. My graph is either going to be above that minimum, above that y value, or it's going to be below that maximum, below that y value. And we'll walk our way through that. Okay. So our job in this section is given just an equation, not a graph. Being able to identify the vertex, axis of symmetry, min or max value, domain, and range. Okay, so it's a 5-part question. Now, this is all going to be based on the form f of x equals a times x minus h squared plus k. And the equation we're working with is f of x equals 2 times x minus 3 squared plus 4. Trying to line it up for you. Okay? Trying to get you to see that this matches up with our vertex form. Okay, matches up with the vertex form that was provided there. First question they're asking is vertex. What are your thoughts, Paul?
3 and 4.
Okay. Because what does this minus 3 tell me to do?
Right.
Because it's in the parentheses, it's left or right opposite sign, so that tells me right 3. What's this plus 4 tell me to do? It's plus 4, so it tells me to go up 4. So first thing I know is that my vertex is 3, 4. Now, keep in mind, when you look at your equation, you're using opposite the sign in the parentheses, yes? And then for the second number, you're using the given sign. What about the axis of symmetry?
3x equals 3.
X equals 3? This is old news, isn't it? Because 3 is my first number in the vertex. So my axis of symmetry is x equals 3. It's always x equals the value, right? And I don't remember, I went through Savas last night. I don't remember if you had to fill in the number or fill in x equals 3 or just 3, but okay, what do they want next? They want to know if this is a minimum or maximum value.
Minimum.
Why minimum?
That's upper left.
Okay, so right here, this 2 is, it's a vertical stretch, but more important, it is positive, yes? A positive stretch or compression is going to tell me that my parabola opens up. And if it opens up, just give yourself a little visual. That puts my vertex at the bottom and makes it a minimum.
Do we just have to go minimum?
No, we also have to give a number. Okay. So they are going to ask you what is the minimum or maximum value. So first off, we identified it as a minimum because the parabola goes only so low, right? Only goes as low as that vertex. How low does it go? What is the lowest value it will hit? What'd you say? 4. Okay. And 4 because it is the
Y value.
y value of the vertex. That's not a coincidence. It's always your maximum or minimum value is always going to be the y value of the vertex. And actually, I just looked at my notes. Told you I don't always pay close attention to my notes. It's because your k value is 4. So when you start asking yourself what's your minimum or maximum value, it's always the k value every time. Okay? The harder part is probably identifying whether it's a max or a min. Okay? 2 more questions. Next one is the easiest all day. Domain. Negative infinity, positive infinity, or all real numbers? I honestly feel like in homework it was a multiple choice and you had to pick all real numbers. And they gave you an option like all real numbers except, but this isn't going to have any except. This is just going to be all real numbers.
Question, does that number change?
If my parabola is upside down? Nope. As long as it's a vertical parabola, which is all we have in Algebra 2, either right side up or upside down, it's always going to be a domain of all real numbers. It changes when we get into sideways parabolas.
You getting
That's pre-calc. Join me next year for pre-calc and you'll get into them.
How will we graduate?
Okay, range. Range is one we do have to think about a little bit. Thoughts on range? How far up and down does this graph go? Tanner?
For infinity.
For infinity. What do you guys think?
Yeah.
I don't know.
Okay, so if I have a minimum value of 4, what's that saying? The lowest my parabola goes is 4. Is it going to touch 4?
Yeah. Yes.
It's going to touch 4, so there's going to be a bracket. Then how high does it go? To infinity. So 4 to infinity. I was just in Savas last night. I don't remember if they did that. Or the other option would be to use an inequality, and then you could say y greater than or equal to 4. I think Savas stuck with interval notation, but I honestly can't remember right now. Okay. It's a 5-part question. I don't think any of the parts are too incredibly difficult, but it is a 5-part question. Here's what I'm going to say. Okay. I'm going to stop here. You're going to continue in these next couple of minutes and try and complete the next example. I will start tomorrow by going over that example. Okay? So that's what I'm gonna ask you guys to do. So if you haven't already, do the example at the bottom of this page to the best of your ability. Okay? And it's very similar, other than you can probably guess instead of a minimum, it's probably gonna be the opposite, right? See what you can do with that. And we will pick up there tomorrow in the notes.